Hi everyone, we're starting video 19 and we're just going to do a brief review of all the different types of factorization. Let's start with the first form of factorization that I always look at initially, which is removing a common factor. So as I'm looking at my first question here, 2x squared plus 6x, I look for my highest common factor to remove, which appears to be, in this case, a 2x, and what's left over on the inside of the parentheses would be an x plus 3. If I now take a look at the next example, I can remove a negative x, that would be my highest factor, and what would be left over would be an x squared plus 5x minus 3. Now, normally we would be able to use a sum and product here because we have a quadratic trinomial at the x squared plus 5x minus 3, but we're not going to do that just yet. We'll be doing that in the next lesson or so. Okay, the next one is 2x bracket x plus 3 plus 4 times x plus 3 all squared. Now, we are removing here everything that is inside the parentheses, so technically I can remove an x plus 3 from the entire expression, and what's left over is a 2x plus 4 plus x plus 3. And then that would just end up giving us an x plus 3, and then we would simplify what's inside the parentheses as 3x plus 7. Now that would be one method in when we are removing a common factor that isn't just a single term but an entire parentheses. Another way of resolving the problem would be to say, if we look at the next example, it would be to say, well, suppose we let a equal 5x plus 2. Now, if I want to remove the common factor here, what I can do is I can say, well, I've got an a squared plus 4a plus 4. And when I am simplifying this, this is really like saying a plus 2 times a plus 2, or a plus 2 all squared. Wherever there is an a, I can now replace it with 5x plus 2, so that I've got 5x plus 2 plus 2 times 5x plus 2 plus 2 again, which gives us 5x plus 4 times 5x plus 4. That would be my factorized form. This would be another method that I could use when I am when I am trying to factorize a situation where I've got more than just a single term to remove. All right. The next method that we could look at would be the difference of squares. Now, if we look at difference of squares, remember that when we are expanding, expansion means that we remove the parentheses. So if I did a times a, that would give me a squared. If I did a times positive b, that would give me positive ab. If I did negative b times positive a, it would be negative ab, and negative b times positive b would give me negative b squared. That would get rid of the middle linear ab term, because I've got a plus ab minus ab that disappear. When I only have two terms, and they are both basically, normally they're going to be perfect squares, but not necessarily. But when I've got only two terms, and I'm missing the middle x term, then and there's a minus in between, that normally means that we are looking at a difference of squares. So what I would end up doing here is I would end up saying, well, take the square root of the first term, which is 3x, take the square root of the last term, which is 5, and then I would write that out twice, but one of them would be positive, and then the other one would have to be negative. Otherwise, there would be a middle x term here if it weren't a difference of squares. So if I look now at the next question, I've got 4x squared minus 36. Well, I take the square root of 4x squared, which is 2x. I take the square root of 36, which is 6, and one of them is going to be negative, and the other one is going to be positive. Okay, and it doesn't matter which order they're in first, whether it's positive, negative, or negative, positive. Now, if I take a look at the next example, again, I've got 25x squared minus 6, but that 25x squared can definitely be simplified, or it can be broken down into a perfect square, which is 5x. But 6 can't be, but it could be brought down to a minus root 6, and then it could just be 5x plus root 6. All right, so those would be your difference of squares. If we're looking at perfect squares, it's not absolutely essential that you know the perfect squares, but it does make your life a little bit easier in recognizing how to the factorization process here. So if I have a squared plus 2ab plus b squared, well, in the factorization process, it means that it's a plus b all squared. We have two identical binomials. So if I give you the example of x squared plus 10x plus 25, well, technically, what does this mean when I say x squared plus 10x plus 25? It means that I'm squaring my first term. X times x gives me x squared. I'm squaring my last term. Well, 5 squared gives me 25. Now, if I did 5 times x, that would give me 5x. But then if I multiply that by 2, then it goes to 10x. And there's my 10x there up on in the second row here. So all we're basically doing is we're following the rule of the perfect squares, which is a squared plus 2ab plus b squared. And all this is saying is I have squared my first term, I have squared my last term, I've taken the product of the two terms and then multiplied them by 2. So I'm doing a check here. I'm taking the square root of the first, I'm taking the square root of the last, I'm multiplying these two together in my mind. Okay, I'm thinking about this, and I'm saying, well, 5 times x gives me 5x, and then I multiply it by 2, and it goes to 10, so I know it's correct. If I were to do the same thing also with the next one, I've got a minus b all squared, well, or x squared minus 20x plus 100, then I take the square root of the first, the square root of x squared is x, the square root of 100 is 10. Now again, in my mind I'm thinking if I take 10 and I multiply it by x, that gives me 10x. But if I multiplied that by 2, it would give me negative 20x. So I know it's correct. It's x minus 10 times x minus 10, which when expanded would give me x squared minus 20x plus 100. Okay, so the general rule basically says is find the square root of the first term and the square root of the last term, and then multiply the two terms together. So in this case it was x times 5 or x times 10, okay, and then multiply it by 2. And if you get the middle term being equal to the middle term that is in your quadratic trinomial in the original question, meaning the middle x term, okay, then we know that we have a perfect square. All right. Now the sum and product. The sum and product is the next one that we look at. And with the sum and product, what we want to do is we want to make sure that our value in front of the x squared in the ax squared plus bx plus c is equal to 1. So we're going to use the sum and product when our value of the a is equal to 1. All right, so in sum and product, what we're looking at is a quadratic trinomial of ax squared, there's my ax squared, plus bx plus c. So my value of the a in this first example of x squared plus 5x plus 6, my value of the a is equal to 1. There's my a, it's 1. My value of the b is 5, and my value of the c is really equal to 6. Okay, now, so in doing a sum and product, I say, what two numbers multiplied together give me 6? So I'm looking for a multiplication of 6. But at the same time, those same two numbers added together have to equal 5. So I open up my two parentheses, and I say, well, I know I'm going to be starting with x and x. And because these are both positives, positive 5x and a positive 6, then these must both be positives as well. And then I just go on to find all my factors of 6. Well, my factors of 6 are going to be 6 and 1 and 3 and 2. Those are my two possibilities. So which one of these two added together is going to give me 5? Well, I think it's going to be obvious that it's going to be 3 and 2. So all I need to do is just add 3 into one parenthesis and 2 into the other. All right, that's my first example. My second example gives me x squared minus 7x minus 18. And I'm looking now for two numbers that multiplied together give me negative 18, but those summed up together have to add up to negative 7. So my possibilities in factors could be 6 and 3, or negative 6 and 3, or 6 and negative 3. They could be negative 9 and 2, or 9 and negative 2, or they could just be 18 and negative 1, or negative 18 and 1. Now I think that of all of these, the ones that will add up to give me a negative 7 is going to have to be negative 9 and 2. So that I can open up my parentheses and say, okay, I've got an x and an x. Now, because the product has to be negative, that means that one of these brackets has to have a minus in it, or a negative, and the other one has to have a positive. Otherwise, if this were positive, then these would have to be either both negatives or both positives, because a positive times a positive gives me a positive, but a negative times a negative also gives me a positive. Since the product is a negative, then one must be negative and the other one must be positive. And I take a look at my sum to decide which number is going to be the negative number. And because it's negative 7, then I'd say it's going to have to be negative 9 and positive 2. All right, so that's one example of sum. Those are a couple of examples of sum and product. Now, we can also look at sum and product, though, even when the value of A isn't equal to 1. So what we normally do, if it's not equal to 1, the value of A, then we look to see if we can remove a common factor first. Is there a common factor that can be taken away from the entire expression? So in this case, 2x squared plus 18x plus 40, the 2 can be removed. So we're left with x squared plus 9x plus 20. Now, once the 2 has been removed, you can just carry that down into the entire solution. Don't remove it. You just take it out and take it outside of the bracket, but you don't just remove it. You just leave it there, and you just keep carrying it down. So I now look at the sum and product that I've created inside the parentheses, and I see that I've got two positive numbers, because they make a positive, and the two numbers multiplied together have to equal 20, and the sum of those same two numbers has to equal 9. So I open up my two parentheses, I place my x and x in both of them. I know that they're both positives, and what two numbers multiplied give me 20 and added give me 9. My factors of 20 are usually 10 and 2, 5 and 4, 1 and 20, and 5 plus 4 seems to be the one that'll work, in that 5 plus 4 gives me 9, and 5 times 4 gives me 20. Okay, the next one is the splitting the middle term. Now, the splitting the middle term is probably the most complicated of these forms, and we'll do it step by step. I'm going to do just one example, and then I'll pretty much be done. All right, so what our goal here is, because I cannot remove this value of 3, the value of the 3 or the value of the A cannot be removed, because 3 does not go into 17, or negative 17, although it does go into 6. However, it does not go into the entire expression, quadratic expression, therefore I cannot remove it. So when I cannot remove it and my value of A doesn't equal 1, then my goal is to multiply the A term by the C term. So I am now looking for two numbers that multiplied together are going to equal negative 18, but the sum of those two numbers are still going to equal negative 17, the middle term. So what I start doing is I start writing out my first term and my last term the way they are. So I write down my ax squared term the way it is, and I write down my c term the way it is. And my goal is to split the middle term into the two factors that multiplied will give me negative 18, but added will give me negative 17. And those numbers happen to be negative 18x plus 1x. Okay. Now, because I have 4 terms here, I can use what we did way back last year, which was divide my factorization. I can factorize by grouping. And therefore, I take my first two terms and I group them together, and I can take the second half or my other two terms and group them together, and I can remove the common factor from the first two terms right here. And my common factor to remove here would be a 3x. And what I'd be left over is an x minus 6. Now, once I've done that, I look at my second half. I have to split now, or I have to take out my common factor from the second half of this. And in removing it from the second half, well, there's really not much that can be removed other than a 1 here. So I can write down just plus 1, and what's left over is still an x minus 6 inside the parentheses. Now, what I've created is a remove the common term type of factorization. So these two inside the parentheses must be identical to each other. And because they are identical, then I can remove them. I can remove one of them, or just remove it, period, so that I have an x minus 6. And what's left over is, once I've removed the x minus 6, so if I showed you this, if I'd been there, if I were there right now, I would show you with my fingers how you would get rid of the x minus 6, but I'll show it to you this way, where I say, okay, well, this x minus 6 and this x minus 6 were removed, which means that they are out here now, and what's left over is a 3x. What's left over is a 3x plus 1. So that's what's been left over, is the 3x plus 1. So now my final solution then is just x minus 6 times 3x plus 1. So that when we are going through the splitting the middle term process, what you want to do first is you want to check to see if you can remove a common factor when the value of a isn't equal to 1. If it can't be removed, then you're going to multiply the value of a by the value of c, so that we have the product of the two numbers is now no longer going to be the value of c, but it's going to be the value of ac together, or a multiplied by c. The sum of the two numbers is still going to be the middle x term, and we're going to split the middle term now. You're going to find what the factors are, and then you're going to factorize by grouping, and then you'll remove a common factor at the end, the way we just did. Okay, and that would be the end of the problem. All right? Okay, let's try to do just one more. We'll try to do just one more over here. Let's take 12x squared plus 7x plus 1. So if I take 12x squared plus 7x plus 1, I know I cannot remove, I can't remove 12 from the entire expression. So what I can do, though, is I can multiply 12 times 1. There's my AC. So my AC is equal to 12, and my sum, so my product is equal to 12, but my sum is still equal to 7. So I start by writing down my first term, 12x squared. I write down my last term, which is plus 1. Oops. Which is still plus 1. And now I'm going to split my middle term into the two factors that multiplied give me 12, but added give me 7. I think the numbers are 4 and 3. So I'm going to write 7x as plus 4x plus 3x. You see that 4x and 3x added together give me 7x. Now, the second to last, we're almost done. What we're going to do now is we're going to split this in half, and we're going to factorize by grouping. So it's going to be 2 and 2, and I'll remove my common factor, which is a 4x in the first half, and I'm left with a 3x plus 1. And then the only thing I can remove in the second half here is only a 3x, is a 1, because I need to have inside the parentheses an identical expression as in the previous one, which is 3x plus 1. Now that they're identical, I can remove the 3x plus 1, and what's left over is going to be a 4x plus 1. And there we have it. We have factorized the second one. Now, the only other thing that I'd really like to go over is just reminding you that when you are using the null factor law, there's a couple of things that we need to remember how to do. One of them being that when you are solving, so in using the null factor law, we are using the null factor law in order to solve the quadratic. Solving the quadratic means that I want to find out what the value of x is. And in finding out what the value of x is, that means that I want to know where what the zeros are, or what are the x-intercepts, the zeros, the roots. So I remove my common factor here. I set everything equal to 0, so whatever my expression is, I bring everything over to one side of the expression and set it equal to 0. So in this case, I've got a 2x and I've got an x plus 3 is equal to 0. And now the null factor law tells me to do either 2x is equal to 0 or x plus 3 is equal to 0. Now again, we went through this in the last class, so that x is either equal to 0 over 2 or x is equal to negative 3, so that we know that our value of x is either equal to 0 or our value of x equals negative 3. That tells me that in the bigger scheme of things, when we are looking at a parabola, that's telling me automatically that I've got a parabola somewhere, and I don't really care at this point whether it's above or below, or if it's facing upwards or downwards. I know it's facing upwards, but I know that it's going through the 0 point and it's going through negative 3, so that those are my x-intercepts. All right. Now, in a situation like the next one, because I've got this 4 that is multiplied by the 5 minus x all squared, I can divide both sides by 4, so that I'm left with just 5 minus x all squared equals 0. And then from there, I can take the square root of both sides. Since the square root of 0 is just 0, I end up with 5 minus x is equal to 0, or 5 is equal to x. So I've actually got only one x-intercept in this case, and it's found at 5. All right. The last thing I just want to mention is the illegal cancellation again. In a situation where I've got x squared equals 12x, I am not, I repeat, I am not going to divide both sides by x and turn it into x is equal to 12, and that's the end of that. Okay? What I would have to do, this is not correct. Okay? It's partially correct. Because if we look at the correct method, okay, the correct method shows us, it shows us that we must bring everything over to one side of the equation. Therefore, x squared minus 12x is set equal to 0. So everything is brought over to... Once they are brought over to the same side, the x squared minus 12x, then we just remove the common factor, which is an x, and we leave out, we have an x minus 12 left over inside the parentheses. And now, using again the null factor law, we have either x equaling 0 or x minus 12 equaling 0. So x is either equal to 0 or x equals 12. Notice that we had the same x equaling 12 in both of these examples, in the correct and also in the incorrect method. But what was missing from the incorrect method was the x equaling 0. One of the x-intercepts, the one at 0, was missing. Okay, I'm done. That's it for today.